Oh, hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abutewa Sos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 7, still on financial maths. It says 7.1, Sarah's investment earns interest at 11% per annum compounded semi-annually. Then Mary's investment earns an effective interest rate of 11.42% per annum. And then they say whose investment, Sarah's or Mary's, earns a higher rate of interest per annum. Now, because we can see that in Sarah's case here, we are just only given the nominal interest rate, but then in Mary's case, we are given the effective interest rate. In order for us to be able to compare this, we would need to convert Sarah's investment interest rate to the effective interest rate, right? So to do that, we say 7.1, we know that's 1 plus I effective is equals to 1 plus I norm over m to the exponent of m. Now to further calculate, let's transpose the 1 over to that other side. So this is 1 plus the I norm. We're going to change this 11% divided by 100. It's 0.11. And then since they say it's compounded semi-annually, we know that semi-annually means half yearly. So that means we have to put 2 here. So in a year, we have 2 half-yearly periods, right? From January to June and then July to December. Right, so if we have 2 here, we know that we must also put 2 there. So for semi-annual, it's a 2 here and a 2 there. For quarterly, it's a 4 here and a 4 there. And then for monthly, it's 12 here and a 12 there, right? So always remember that. Then when you punch all of that into your calculator, you get 0.113025, and then which obviously you will then need to multiply by 100 so that you get your interest rate, right? So I effective is equals to 11.30%. Now comparing the 11.30% received by Sarah and with the 11.42% received by Mary, we can then conclude that therefore Mary earns a higher rate, because for Mary it's actually 11.42%, right? Okay, so that's all you were supposed to do there. Let's now proceed. Okay, so we have 7.2. It says Buhle decided to start saving before retirement. She makes payments of 10,000 Rand monthly into an account yielding 7.72% per annum compounded monthly, starting on 1 November 2016 with a final payment on 1 April 2026. Then 7.2.1 says calculate how much will be in the savings account immediately after the last deposit is made. So now the biggest challenge with this question was finding the number of payments that have been made between 1 November 2016 to 1 April 2026. So let me break it down for you. Now, agree with me that from 1 November 2016 all the way to 31 October 2017. This is where we're going to have a full year, right? So a full year will be represented by this period here from 1 November 2016 all the way to 31 October 2017. That's a full year. So if I can say from 1 November 2016 all the way to October 2025, this is what will happen. So November, December, January, February, March, April, May, June, July, August, September, October, right? So that's a full year. And then payments will be made here. So every first of the month, we make a payment on this month, right? We make a payment. So this will be going on for how many years? From 1 November 2016 to October 2025. We do understand that in between here, that's 2025 minus 2016, that's equal to 9 full years, right? So this will be taking place for 9 full years. But then as soon as it's now November 2025, all the way to the final payment, which is on 1 April 2026. This is what will happen. So November, December, January, February, March, April, May, June, July, August, September, October. So within this period here, on the final year, only 6 monthly installments will be made. So in November, December, then we go to 2026, January, February, March, April. Then it stops here. So these other months, they're not making any payments because the final payment, it is made on the 1st of April 2026. So now we want to find out how many monthly installments will be made in total. Remember, from 2016 to 2025, November to October, there was 9 full years, meaning that in terms of months, that's 9 multiplied by 12. So how many monthly installments were made within that 9 full years? That's 9 multiplied by 12. We get 108 monthly installments, right? Or monthly payments. But remember, from November 2025 to 1 April 2026, only 6 payments were made. So in the total number of payments, right now will have to be 108 plus the 6 payments that were made here, and then we get 114 monthly payments. And then just like that, you have found n, right? You have found n. So that's the n that you were supposed to use there. So now that we have broken down that, and then we understand how we came about with the n is equal to 114, let's now answer that question. So obviously this is future value because, as the statement suggests, Buhle is making this monthly deposit into the account, into a retirement fund, which she expects to have grown to a certain future value after those number of months or after the investment period. So we're going to use future value formula. There we go. And then what's X? X is the regular installments that are made. Then 1 plus the interest, 7.72%. So this divided by 100, it becomes 0.0772. Then over 12. And then for N, that's where we put the 114. Over 0.0772 over 12, right? Then all you have to do is simply punch all of this into your calculator. Then you get 1,674,501.44, right? So that becomes your value there. Okay. Now let's proceed to 7.2.2. Okay, so now let's look at 7.2.2. It says at the end of the investment period, Buhle reinvested the full amount in order for her to be able to draw a monthly pension from the fund. Now understand this statement here. Remember, Buhle has already invested this money and then she got an accumulated amount of the one that we got here, 1,674,501.44. But then what you need to understand right now is that this is now a present value situation because she now has the money on her hands or on the still on the investment platform, but now she's willing to draw from the pension fund, right? So if now there is a decrease in annuity, that's present value. If there's an increase in the annuity value, that's future value. So right now she's only reinvesting the money, but only for the purpose of withdrawing every month, right? So understand that If she's now withdrawing from the investment or she's now withdrawing from the pension fund, that means it's now present value because there will be a decrease in that annuity, right? So she reinvested the money at an interest rate of 10% per annum compounded monthly. If she draws an amount of 30,000 per month from this investment, for how many full months, note this, for how many full months will she be able to receive 30,000? So right now, the retirement fund is paying her the monthly deposit. So we want to say for 7.2.2, we are dealing with a present value situation. So PV, x 1 minus 1 plus I to the exponent of negative n over I. Now the future value that we got in 7.2.1 is now the present value. So 1,674,501.44, and then the monthly withdrawals that are made are of 30,000. Then we have 1 minus 1 plus 0.1 over 12 to the exponent of negative n. So we are looking for that n there, over 0.1 over 12. So we know the first thing that we do with this questions, first divide by the value that will be here. So I will divide both sides by 30,000, right? So it's the same as saying 1 over 30,000. Now when I divide by 30,000 here, the value that I get is 55.8167. I'm just going to round it off to 4 decimal places. Then immediately, you know, I cross multiply with that value there. 0.1 over 12 is equal to 1 minus bracket 1 plus 0.1 over 12 to the exponent of negative n. Right. Now to further calculate, we know that we will have to take this one over to this side. So that's bracket 1 plus 0.1 over 12 to the exponent of negative n is equals to 1 minus, take this one over to that side, 55.8167 bracket 0.1 over 12. Right. Now when we punch all of this into our calculator, what do we get? So we find that our value is equals to 0.53486, 5 decimal places. Then to calculate n, it's n is equals to negative log base as this one, 0.1 over 12, and then put this one here, 0.53486. Right. Now when you punch that in your calculator, it gives you a 75.40. But then remember, I made you note that they said full months. How many full months? So remember, the 0.40 here is indicating that the final payment will not be exactly 30,000. It will be an amount that is less than 30,000. So we have seen questions whereby they might ask you to calculate that final payment that will be made. But then to comment on this one, the full payments, we have to see them on the number here that is before the comma, right? So this is not about rounding off. It's just about having to take the number that is before a comma here. So even if it was 75 point, let's say 90, I would still say it's 75 here, because we always take the number. If they say full payments or how many full months, then we always take the number that is before the comma there. So we'll say therefore n is equals to 75 full months. So she will get that 30,000 for 75 full months. So there will be a payment of the 30,000 for 75 consecutive months. Okay, nice. Then let's now look at 7.2.3. Okay, so we have 7.2.3. It says after withdrawing 30,000 for 20 months, Buhle requires 1,500,000. Determine whether she can access this amount of money from this annuity, right? So note that in the previous question, we concluded that 75 monthly installments of the 30,000 will be made to Buhle through the retirement fund or through the annuity. So now this is a question on the outstanding balance. We are trying to find out that if already 20 monthly installments are made to Bull, will she still have an amount of 1,500,000 in her annuity fund, right? Or in her retirement fund. So that means what we are supposed to do is obviously find the remaining number of installments that needs to be made to her. So that's 75 minus 20. We find that she is remaining with only 55 monthly installments to be made to her of the 30,000. So okay, to calculate that, we're still going to use the present value formula. 1 minus 1 plus I to the exponent of negative n, and then over I. Then we can edit it to say outstanding balance, because that's what we are trying to find. We are trying to find the money that is still remaining in her annuity fund. So X is 30,000. So we have 1 minus 1 plus the interest, still 10%, 0.1 over 12. But then the N right now is what? 55. So we're going to substitute 55 over there. And then over 0.1 over 12, right? Then our outstanding balance, we just simply press in our calculator. Then we find that what's remaining in an annuity fund is 1,319,260.60 cents, right? Now from this, what conclusion can be drawn is the fact that she will not be able to access this money because it's not even in an annuity fund. This is what she's left with in the annuity fund. So that means no, she will not be able to access that amount. She will not be able to access that amount. So our conclusion, right? So that's how you were supposed to go about tackling that question, all for just a total of 15 marks. So please press the thumbs up button if you have enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.